Okay, boys and girls, today we're starting our unit on trig functions. And before we could do that, we just need to remember how to simplify radicals. So if you recall that the square root of 4 is 2. And what that means is that 2 times 2 is 4. Or let's say the square root of 9 is 3 because 3 times 3 is 9. And these are our perfect squares that we normally don't really think about. We just kind of take it for granted. The square root of 16 is 4. So when we have a radical like the square root of 24, there are no two numbers that we can, there is no number that we can multiply by itself and get 24. However, there's a mathematical rule that states a radical is simplified if it doesn't have a perfect square as a factor. So if we think about 24, 24 is 4 times 6. So 4 is a perfect square. So therefore, the square root of 24 is not simplified because it has a factor 4 that's in the radicand. So we're going to do this. You can do it a couple of different ways. The way that I'm going to show you to do it is what we're going to do is we're going to take this 24 and we're going to write the prime factorization of 24. So like 4, 24 is 4 times 6. I can break 4 down to 2 times 2, and we can break down 6 to 2 times 3. So now what we're going to do is, because if there are two of them, if it's a pair of it, it makes it a perfect square. So the pair is going to go out. So this is like saying the square root of 4 times the square root of 6. Well, the square root of 4 is 2, and what's left is the square root of 6. Okay? Now, in this next one, 300, you may be able to tell what's left easily, but if not, we're going to just take it down to the prime factorization. And remember, a prime number is a number that's only divisible by itself in 1. So what two numbers can I multiply to get 300? Well, I can do 3 times 100. That's an easy one. Well, what can I multiply to get 100? 10 and 10. Which is 2 and 5, and 2 and 5. So what are my pairs? Well, I have a pair of 2s, and I have a pair of 5s. So the pairs are coming out. 2 times 2 comes out to 2. 5 times 5 comes out as 5, and then what stays home? What is left stays home. So I can write that the square root of 300 is 10 times the square root of 3. Well, what do I do with the 2 that's outside of that? Well, I'm just going to multiply by that 10, and I get negative 20 radical 3. And that is my final answer. Okay? I can't multiply what's outside the radical with what's inside the radical. The two of these don't talk to each other, so this is not the square root of 150. Okay, because what's inside the radical can't be multiplied with what's outside the radical. So let's try 50. So we take 50. What two numbers can I multiply to get 50? 5 and 10. What two numbers can I multiply to get 10? 2 and 5. So where are my pairs? My pairs are going to be, I'll get a different color, green, the 5 and the 5. The pairs come out, so I have 3 times the 5 that came out, and then what's left inside is whatever's left is left inside, so that's 2. So my answer is going to be 15 radical 2. The 5 that came out times the 3 that's in there already. Now, you may notice and say, wait a minute, now we're adding letters. Yeah, so we have to be able to do this as well. But we're going to do it the exact same way. We're going to start with the 75. So what can I multiply to get 75? 5 times 15. And then this is 3 times 5. Okay, so my 5s are coming out. Now what about this a cubed? Well, I have a cubed is a times a times a. I need 2 of those a's to come out. So I take out that pair. So what comes out is the 3 is already there, and then the 5s come out, and then the a comes out, and what's left is 3a. 3 and an a is left, so that goes inside. Okay? So we have -4. I'm sorry, I don't know why I wrote that -4, but it's out there, and now we have to do 16. Well, you may already notice that 16 is a perfect square. The square root of 16 is 4. So when I take the square root of 16 and multiply times the -4 that's already out there, I get -16. X, y to the 4th. So let's take our variables, x, and then I have 4 y's. Now remember, I need a pair to come out. So I have this set and I have that set. I have 2 sets. So everything is multiplied together, and that's going to be -16. That's a pretty little triangle. That's -16 y squared, and then radical x remains inside. Okay? This negative is on the outside. That's different than the negative being inside, which we're going to talk about later. So, as a matter of fact, why don't you pause the video and see if you can't do this problem by yourself, and then come back. Okay, welcome back. So hopefully you have an answer. I'm just going to walk through it. 84. What 2 numbers can I get to multiply to get 84? If you don't know where to start, if a number is even, start there. So I know this ends in a 4, so it's even. So that's going to be 2 goes into 84 42 times. And then 42, again, it's even, so 2 goes into 42 21 times. And 21 is 7 times 3. So who went out? The 2 2's went out. The negative is still out there, so that's 2. And then who's going to stay inside? We're both the 7 and the 3. Let me do that again, because it's kind of hard to see what I wrote there. So let me just write that again. Just kind of, and let me get a different color as well. I don't like the color. Let's go to black. I don't think that's black. All right, so we have 84, and then we did 2 and 42. And then we had 2 and 21, and then we had 7 and 3. And so the 2's came out, so that 2 came out, and the 3 and the 7 stayed home and multiplied, so that became 21. X to the 5th, that's 5 x's. And they're coming out in pairs. So that's going to come out as x squared. So we have -2 x squared, and then z's. Right now you should be seeing the pattern. 2 of them are coming out, so that's just going to be z, and the x and the z will stay home and multiply. So that's xz. So we have 21 xz because neither one of those had a pair. Okay? All righty? So that's how we do that. And now we're going to move. Notice in these before there was no index here. And remember in last unit we talked about how if there's no index, that index is understood to be 2. So we had to have a pair in order to go out. Now because my index is 3, we have to have 3 of a kind in order to go out. So if I take 81, it's 9 times 9, and then 3 times 3, and 3 times 3. Because we're looking for a cube root, now I need to have a perfect cubed, which would be, I need 3 of them. So 3 comes out, because now it's the cube root, so I need 3 of them. So the 3 comes out. Don't know sure what I did there. And then what's left? It's the cube root of 3. That was a lot of 3's. All right, let's do 24. Again, we're looking for the cube root of 24, so I need a pair of 3. So 24 is 2 times 12, which is 2 times 6, which is 2 times 3. So again, because this is a cube root, we need 3 of them. So that 2 comes out, and what's left is the 3. Okay, why don't you pause the video and try to do the cube root of 108. Okay, welcome back. All righty, so the 108, remember we need 3 to go on a date. So what 2 numbers go into 108? It's even, so I'm going to start by doing 2. And 2 goes into 108 54 times. What can go into 54? 2 and 27. And then 27 is 3 times 9. and that's 3 times 3. So, oh, look, I have 3 that can go out. 1, 2, 3. And I'm going to multiply times the 5 that's there. So that's 5 times 3, the cube root of, and then I multiply what's left. So 2 times 2 is 4. So that goes inside the house. And so we're left with 15, the cube root of 4. Now, 4 is a perfect square. It's not a perfect cube. So we can't simplify that. Be careful of the indices there, the indices. All righty, let's look at this problem again. It's similar to what we've done before, but now we're just adding a variable. So we have 40, which is 5 times 8, and 8 is 2 times 4, and then 2 times 2. Oh, look, we have 3 of them, so the 3 comes out. Now, this x to the 4th, how many do I need to go out? I need 3. So I have 3 of those, so the x's will come out as 1, and I'm left with 5 and an x. Okay, 250 is going to be similar, so let's just do, why don't you pause, as a matter of fact, pause the video and do the last 2, and then we'll come back and talk about it. Okay, welcome back. We're going to start with 250. I know that is 25 and 10. And 25 is 5 and 5, and 10 is 2 and 5. So look, I got 3 of them. They're coming out. X to the 6th. I have 3 here, and I have 3 here, so that comes out as x squared. Y to the 5th. Take out 3, and I'm left with 2. So what am I left with here? Okay, so I have the 4 that's on the outside times this 5 times x, because I have 2 sets of 3's, and then 1 set of y's. And what's left here was 2. There was only a 1 left with the x's and y squared. So my answer is 20 x squared y, the cube root of 2y squared. And my boxes are not nearly big enough. Sorry about that. But that's my answer. My boxes are not big enough. Let me make my box bigger for this next one. All right, 135. What goes into 135? It ends in 5, so I know it's divisible by 5. So I could do 5 goes into 135. 1 times 10, 35. Is that right? I bring down the 3, bring down the 5, and I'm left with 17. So, is that right? I thought I think I may have meant that to be a 125, but that's all right. We'll go with what I have. So 5 goes into 135. Maybe I did my math wrong. There should be 2. I did my math wrong. 2 times 5 is 10. Subtract, I get 35. 5 goes into 35 7 times. So 135. When I break that down, I get 5 and 27. And then 27 is 3 times 9, which is 3 times 3. So there we go. So these 3's come out. So I got a 3 that's coming out and a 5 that's left inside. Then I have x to the 4th. So I have 1 set of 3's that's coming out, and that x is left there. And then I have y squared. I don't have enough to make a cube. I don't have 3 of them, so that y squared is just going to stay there. So this is going to be the cube root of 3x times 5xy squared. Okay? All right, now we're going to go to what if negative is inside the radical. Now this only matters if my index is even. If this had been the cube root of 8, the answer would have been -2. But because it's the square root of 8 and you can't take of -8 and you can't take the square root of a negative number, By definition, we define the square root of -1 as I. That's the definition. You may not like it, it's just by definition. So that's what that is. So we can now write this as the square root of -1 times 8. Okay? So the square root of -1 we know is I. So I can write this as I radical 8. And then I just break up 8 as I would have anyway. Because it's a square root, I'm back to looking for pairs. So the 2 comes out. So I would say this is 2I square root of 2, because that's what's left. Okay? So what we have to remember is that the square root of -1 is I. So we can write this as I square root of 20. So again, we're going to break down 20. 20 is 2 times 10, and then 2 times 5. It's the square root, so I'm looking for a pair. The 2 comes out. Ooh, I don't know what happened there. We get 2I square root of 5. Okay? Can you try this third one? Okay, welcome back. Again, we're going to write this as I square root of 48. And then we're going to break up 48 into 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. Okay, so what do we have? We have one set of 2's. We have another set of 2. So together they go out, and that is I times 2 times 2. And then what's left stays in the house. I'm not sure why that's doing that. It's getting on my nerves. And that's going to be 3. So my answer is 4I square root of 3. Now these at the bottom are exactly the same. It's just I added variables, but we've already done that as well. So I'm going to encourage you to pause the video and try to simplify them and then come back. Okie dokie, welcome back. So we know this is going to be I square root of 35x squared y cubed. Now, 35 is 5 times 7. And there are no pairs there. There's nothing that I can take out. So I can't simplify that any further. So that is just going to remain 35 because there's nothing I can take out. Then I have x squared, which is x times x. And I got a little crazy there. It's just x times x. And both of those come out, and that's just going to be x. And then y cubed is y times y times y. So I circle 2 of them. I have a y that's coming out and a y that's staying in. So my answer is xyi square root of 35y. Okay? Negative 108, again, and I have that 6 outside, but that's okay. So I know that it's going to start as 6i, the square root of 108 x squared y cubed. So let's break down 108. I think we've done this before. That's 2 times 54, which is 2 times 27, and that's 3 times 9, and then 3 times 3. So I think when we did it before, we did it as a cube. Now we're doing it as a square root. So I only need 2 to take out. So I have the 2 here, this pair of 2, and this 3. So both of those are coming out. So I have 6i times 2 times 3. And what was left here was a 3 that stays in the house. Then x squared, by this time you should realize both of those will go out. So I have x. Y cubed, 2 will go out, 1 would stay in. And that's my answer. So my answer is 6 times 2 times 3, which is 36i xy, and then the square root of 3y remains inside. Okay? Negative 27. So remember, this is going to be 4i, the square root of 27x to the 5th. And it should be a point where some of these you should be able to look at them and do them in your head. So this is going to be 3 outside. So this is 4 times 3 times I, and then a 3 is left inside, and x to the 5th I have two sets of x's that's coming out. So that's going to be x times x, and then one x left in. So that is 12ix squared, square root of 3x. Okay, now, I think that's all we're going to do in this video. Come back to the next video, and then we're going to multiply and rationalize.